What's up, everyone? Today we're looking at tandem cylinders. So we have one cylinder upstream and one cylinder downstream, and we're looking at how the von Karman Street forms over both of these. I did a podcast about 2 months ago that looked into something like this. It's called Cactus Inspired Aerodynamics. I'll link it in the description. That was a pretty cool podcast, so check that out. Here I have, as I said, these two cylinders. One is 5 diameters downstream from the other, and they're directly in line with each other. So the flow, which is going from left to right, is going over the first one and it will impact the second one. And I did this to see how the von Karman streets of these two interact and what happens. It's quite interesting. So I'll play the video, and we have actually the vorticity magnitude, so the absolute vorticity. And so you can see for the first cylinder, you do have this von Karman street forming. It's very familiar, and that's impacting the second cylinder. But as soon as you impact the second cylinder, it kind of kills the first von Karman street and then just creates the second one. Or I guess you could say maybe they merge. That would be a better way of putting it. So the second cylinder, it has its own von Karman street, but there's almost no relevance of the first von Karman street. So the second cylinder really overtakes it and somehow merges it or makes it weaker from the first one. And then you get a familiar von Karman street forming downstream. And this video is the U magnitude. The flow is going from left to right, but because there are these vortices being formed, the flow does get churned up a little bit. And so as we play it, you can see that these low velocity regions are hitting the second cylinder. And interestingly, as you go downstream, they do dissipate, so that's good. Then the ones coming from the second cylinder, you can see coming downstream, seem to dissipate probably a little bit quicker. And I would sort of say that the wake of the second one is a little bit like the really intense wake is a little bit smaller than the first one. So you can see there, like, for example, how long this blue region is from the back of the cylinder. Here it's very short, and I'll keep your eye on here, and you can keep an eye on to how short it is. So that's pretty cool. And you can see these low velocity regions, which are corresponding to the regular von Karman street we're familiar with. And this video shows the UY velocity. So this is the velocity up and down. Red is up, blue is down. And again, the front cylinder, I'll play it a little bit and watch these two regions here. You'll see them starting to wiggle a little bit. So you can see they get a little bit more intense, a little bit less intense as the flow goes. So that shows that there's this downstream flow is impacting the upstream flow. It's having this feedback. And now this second cylinder downstream, another interesting thing is when you watch, so for example, we have this very red region here, which means that the flow is moving up, impacting the second cylinder. And just behind, we start to get some flow which is moving up as well. And watch that flow behind grow. So here, this just a moment later, that original flow going up has now reached the cylinder, and then there's a lot more flow behind it going up. So there's this sort of partnering of these two flows ahead and behind the cylinder to create this von Karman street. And it happens with the blue as well. Right, so that's it. Make sure to check out the Atmosphere Hawk. This is an instrument that accurately measures the temperature, barometric pressure, and humidity in your experiments, which means that your density that you calculate is going to be far more accurate, which means you can trust your results much better. It will make your life better. You will love it. Go get one. Link in the description.